All right, let's pick up where we left off with some algebra problems, multiplication, division, and factoring. Let's work with factoring. Simplify this by factoring it.
Is it x to the fourth y?
No. Well, let's talk about that answer. First of all, if I have this, I do not have x to the fifth. In other words, you cannot add apples and oranges. That is an apple, that is an orange. So I would not be able to add those even if I take away that y, it looked like you just added the 4 exponents. Remember, you only add exponents when it's multiplication. In other words, if I was multiplying x squared times x to the third, that would be equal to x to the fifth. Okay? Yeah. So keep in mind that multiplication and division are the easy things to do. Addition is the tough thing to do. So if you're always questioning whether you can add something, make sure it's the same thing. I can multiply apples and oranges, but I can't add them. When we're talking factoring, what we're doing is talking about turning this thing into a product. In other words, if I look for the greatest common factor, it's x. Yeah. The definition of the greatest common factor means that I'm going to be able to divide every term by that greatest common factor, and it's going to come out even. Okay, so I write it like this, x times, what's the first term? What's x squared divided by x?
X.
Okay, and after you do that step, always make sure you multiply it back together again just to make sure. Okay, and what's the next two terms?
And it's still xy?
No, we got to divide that by x. In other words, when you factor out a greatest common factor, you're going to divide every single term by that factor. So if I divide that by x, what do I get?
Y.
Okay, that's what goes there. And then x divided by x, what do I get?
0.
Nope. When you cross it out, when I do stuff like that, it doesn't mean 0 is left behind. It means a 1 is always left behind. So plus 1. Now, before you go further, make sure that you have what you started with. In other words, we're never changing anything when we factor stuff out. Because all we're doing is changing it to, I'm now multiplying this entity x by this entity x plus y plus 1. And the advantage of factoring is, if I say that's equal to 0, I have no way to solve it. If I say this is equal to 0, I can solve it. One of the most fundamental rules of algebra is that if you have multiple things multiplied together, 2 or more, and they're multiplied as 0, then one of them has to be 0. So if I can write something like that, it gives me a lot of progress. I now know that either this thing, x, is equal to 0, or this thing, x plus y plus 1, is equal to 0. So it gives me a lot more options if I can state something as the product of something instead of just the sum. Notice here we have the sum of 3 things that are all different. That's an apple, that's an orange, that's a pear. Okay? I cannot add those 3 things together. So that's the whole purpose of factoring. All right, let's do some more factoring things here. And the very first thing you learn about factoring is taking out a greatest common factor. That is the first thing you always look for. What is that going to be?
Y.
Okay, what's left?
Y squared. And Y
Plus, don't forget the plus sign.
plus Y.
What's 2y squared divided by y?
Y squared.
What about the 2? What happened to the 2?
Makes it a 1.
No, I can divide the y squared by y, and that turns into y, but I still have the 2. In other words, my answer is that. And to understand why that's the answer, multiply them back together again, and you get this. That's what has to be true. In your head, every time you do something like this, at each step of the way, make sure that you haven't changed it. What's the final number?
1.
Okay. That's good. Now, the question said fully factor it. Well, this thing right here, I can factor more. Let's talk about factoring. In other words, finding a greatest common factor is actually the easier part of factoring. This is where it gets hard. When you take a quadratic let's make everything an x, just to be as less confusing as possible. Do you know how to factor that? What have they taught you for factoring? Have they taught you something called the California method, the diamond method, or just the trial and error method?
Just the trial and error method.
Good. So that's what we're going to work on that today. There's no skill that you're going to need greater in algebra than factoring. So, let's write down our steps. I'm going to teach you my method. Okay? Step 1. Step 1. Separate the x squared term. By separating it, I mean that must come. We learned ET last time. Let me do this one for you. Separate the x squared. Okay, it means splitting it up. Well, this times this has to produce this after I multiply it back together again. So that's an easy step. Second, figure out both signs. And this is the one everybody wants to skip, and that's why they have problems. Both signs. What are both signs? Have to be based on the fact that that is a plus. In other words, the only way you're getting a +1 here is if both signs are the same. It either has to be minus, minus, or it has to be plus, plus. Okay? That's important.
Okay.
If that were a negative sign, then it would have to be plus, minus. The fact that that's a positive sign means they both have to be the same, which means they are always whatever the middle sign is. In this case, because the middle sign is plus, and I know they both have to be the same, then it's plus, plus. That's step 2. Step 3. Factors of the constant. In In other words, factors of the number 1, but it's not always going to be a 1, that do what? Because that's a plus sign, they have to add to the coefficient of the middle term. For right now, that's all you need to memorize. It's going to get a little more complicated as we make these more complicated. What factors of 1 add to 2? Well, clearly 1 and 1. In other words, if I multiply x plus 1 times x plus 1 using whatever you want to call it, ET, or FOIL, I'm going to get x squared plus 2x plus 1. So, in effect, what factoring is the reverse of multiplying two linear factors together. But always use these 3 steps, okay? Now I'm going to make them harder. Do these 3 steps and factor this.
So it's x plus?
Let's do the first step. That's step 1. Now let's figure out what both signs are. Not just one at a time, but both signs. What must both signs have to be?
Plus.
Okay. And finally, the third step. Express it out loud. We need factors of 10 that do what?
And add them to the middle term.
So express it out loud by saying, I'm looking for factors of 10 that add to the number 7. What are they?
5
I need both factors.
of 10.
Yeah. In other words, it's not just 5, it's 5 times 2. When I say factors of 10, I mean the two numbers that multiply to 10. Well, in this case, 5 and 2 work perfect, and it doesn't matter if I put the 2 over here or the 5 over, or the 5 there. As long as I have x plus 5 times x plus 2, I'm going to get this quadratic. Okay. Now, I'm going to mix it up a little bit and put a negative sign there. So, what are my signs?
Plus and then minus.
No, if they were plus minus, they wouldn't multiply together as plus 10. Notice that if I have plus minus, no matter what numbers I have here, the fourth step that produces this constant is multiplying those two numbers together. Well, if I had plus minus, I would have a minus sign in front of that 10. So the fact that that 10 has a plus sign in it tells me that the signs have to be the same. They're either plus plus or minus minus. What are they?
Minus minus?
Yeah, because the middle term has a minus sign on it. And now, the third step is still the same. Factors of 10 that add to 7. And don't worry about adding to negative 7. They just need to add, because of that, to the number 7. Well, same two numbers, 5 and 2. And there's your answer. Now we're going to make it harder still. Start me off.
So you put the x and the 2.
What are both
And
signs?
then my subtraction.
No. They have to be opposite. See why they have to be opposite? One has to be positive, one has to be negative. Why? Because somehow, after multiplying, whatever numbers are attached to this thing, hold on, my pen has gone bad on me. Hold on. Trying to figure out what I have done so that this thing is off. So they have to be opposite, okay? And it doesn't matter if I have the plus on that side and the minus on that side, as long as the coefficient of the x term is 1. Okay, keep that in mind. What we're doing is what I call level 1 factoring. Level 1 factoring of a quadratic, where it's always x squared here. It's not 2x squared or 3x squared. It's always x squared. All right, so I know the signs have to be opposite, because otherwise I would not be able to produce a negative 10. Well, now I'm looking for factors of 10 that subtract, not add, subtract, because of that negative sign that's in front of the 10, to the number 9.
10 and 1.
Okay, and take the larger of those factors, the 10, and put it with the sign of the middle term. So the 10 goes there, the 1 goes there. All right, let's do some more of those. That is, let me think for a moment. It's the number 12. Hold on. Okay. So.
You put the 2 x's beside the 10. And then the plus and the minus.
Now what's the rule? Verbalize the rule for me.
That you have to find the factors that's level and then add them
Hold
to
it.
the middle term.
First of all, you're right. It's factors of 12, but I want them to subtract to the coefficient of the middle term, not add. I want them to subtract now. Whenever this is a negative sign in front of the constant, you want them to subtract. To what number? The coefficient of x. What's the coefficient of x?
1.
Yes. So I'm looking for factors of 12 that subtract to 1. What are those? Okay, let's go through the factors of 12. The way I taught you how to do it. What's some more?
4 and 3.
Okay, that's as much as you got to get to. There's the 2 we're looking for. Where does the 4 go? Where does the 3 go?
The 4 goes on the Minus?
Yes. In other words, the larger of these two factors, whichever one is the bigger number, goes with the sign of the middle term. Well, okay. This is why it's so important that you know your multiplication and division tables. Otherwise, it's hard to factor numbers. In other words, whenever you're factoring quadratics, you need to be able to factor that last number, always. And it's virtually impossible to do that on a calculator. In other words, the calculator doesn't have a factor this number key on it. So the only way you can do it is to know your multiplication tables. But I'm confident that you're learning those pretty good. The last couple times we've checked, you've done real well on it. So what's next here?
You put the 2 plus n.
What are the both signs?
Addition.
What's that sign?
Subtraction.
If both signs were addition, I would have a plus in front of that 36. Right? In other words, if I got plus plus, the last step that I'm going to do when I multiply these two back together again is multiply whatever that number is times whatever that number is. Both going to have pluses. I'm going to have a plus up here. So you have to work backwards here. You have to start with what this sign is there, and that tells you what these signs are going to be. They have to be opposite. They have to be opposite. That's the only way you can produce a negative 36 is with opposite signs. And I don't care whether it's minus plus or plus minus. For the moment, I don't care. Now, verbalize the last thing we need.
The find the factors of the and subtract them.
Verbalize it entirely. Factors of 36 that do what to what?
Factors of 36. Add them.
No. Subtract them because of that again. In other words, this sign is extremely important. It not only tells you what both signs are going to be, but it also tells you whether the factors need to add or subtract to that number. So we need them to subtract to 5. Start factoring that. Factor it down. Factor it down the way I taught you. Can you cut this one in half and double this? That'd be 18 and 2. Do it again.
6.
Cut it in half and double this. Always do the easiest thing you can do, which is to cut in half. If you can still cut it in half, keep going down that route until you can't do it anymore. Then if you can cut it in thirds, do it. But at the moment, I can cut this one in half and I can double this one. Now I can't do it anymore. I can't cut this one in half. I could cut it in a third and triple this one. Let's try that. That's going to give me a couple more factors. Okay. And I think that's all of them. Which two do what we need them to do?
9 and 4.
Okay. Where's the 9 go? Where's the 4 go?
9 goes with the factor sign.
With the what?
9 goes with the X.
Well, there's both x's there. The 9 goes, the bigger of the factor, remember that, the bigger of the factor goes with the sign of the middle term. So it's huge what these two signs are. The most important part of this quadratic is this sign and this sign. Okay? So the 9 needs to go with the plus sign because the middle term has a plus sign on it. Notice why. Let's not end this here. When I am checking this problem, after I've got it done, rather than go to the next problem, I'm going to make sure that it's correct. Well, normally I would have to ET it. And, I would get x times x is x squared. X times plus 9 is plus 9x. X times minus 4 is minus 4x. And minus 4 times plus 9, that last step is minus 36. Well, that works. It's x squared. When I simplify it, x squared plus 5x minus 36. That's what I started with. So I did it correctly. But I don't need to FOIL the whole thing. What does that sound? It keeps going on.
Oh, that's my phone going on.
Oh, okay. When I'm checking this thing to see if I've factored it properly, I don't really need to check this term here. I split that apart pretty easy. Splitting it into x and x is, you're not going to make a mistake there. I also don't need to check that I got that number right. The whole process of factoring is predicated on this factors of 36. So unless I did my math wrong, I know that I don't need to check that term. The term that needs checking is the middle term, always. Well, you get the middle term from multiplying the two insides together and the two outsides together and adding them up. Well, the insides are minus 4x. The outsides are plus 9x. And they add to 5x. So I got it right. And that's all I need to check. So when you're checking your quadratics, you don't need to check it by completely multiplying it out. You just use what I call my double smiley face method and check the middle term only.
Okay.
We're going to stay with level 1s today. But I want to make sure that you've got it down. Do this one.
Are they
I've done
subtraction and addition?
I've done step 1. What's step 2?
Figure out both sides.
Okay, what are they?
Subtraction and addition.
If they were subtraction and addition, what would the sign on that number be? You have to be able to work backwards.
Negative?
Yeah, it would be negative, right? And it's not negative. Therefore, it cannot be a negative and a positive.
So it's both positive?
Well, they both have to be the same. They don't have to both be positive. They could both be negative. You produce positives when you multiply by multiplying either a positive times a positive or a negative times a negative. In this case, which one is it? Is it plus plus or minus minus?
Minus minus.
Right, because of the sign on the middle term. This takes priority, and then we look at that. Okay? So it's minus minus. And verbalize the last part.
Find factors of constant.
Well, say the number. Factors of 36 that do what?
and then add them to the coefficient?
They need to add to what?
13x.
Not 13x, 13. So factors of 36 that add to the number 13. That's the rule. Okay, what are those numbers going to be?
9 and 4.
And it doesn't matter whether I put the 9 there or the 4 there. Since there's negative signs in front of both, these are equal, whether I said x minus 4 times x minus 9 or this way. All right, we'll do more factoring next time. Factoring is something that we never can get too much practice at. In other words, if you can get really good at factoring, you've made huge leaps towards algebra.
Okay.
Okay? All right, Jenna, I will talk to you on Wednesday.
Okay, thanks. Bye.